The SIP Sender is an automated home drink delivery system. Our goal was to create a system that could deliver drinks to you from the comfort of your couch without ever needing to move. We arrived at this idea by considering various robots for our design topic before asking the question, what if the robot could bring you a drink? As far as requirements, specifications, and constraints go, we wanted the SIP Sender to be developed for less than $300 in a 3-month time frame and to operate on less than 1200 watts. We wanted the SIP Sender to be operated via key phrase activation through an Amazon Alexa, to be remotely targeted, and for the system to seek verbal confirmation before firing. We also want the SIP Sender to have a 20-foot range of delivery with a 2-foot margin of error, and for the entire cycle process to take less than 20 seconds.
The SIP Sender can be broken down into 4 subsystems. The catapult, which includes the solenoid clamp and the crank motor, the drink hopper loader, the horizontal targeting platform, and Amazon Alexa voice activation.
The catapult is wood-framed, constructed of 2x4s with force provided by an extension spring and bungee. The arm is cranked down by a Ryobi 18-volt drill motor wired up to a motor controller. The catapult rope is spooled around a long drill bit attached to the drill's chuck. The trigger mechanism utilizes a 24-volt pole solenoid and U-bolt configuration to clamp the catapult rope while the drill motor is unwound back to the arm's neutral position. The solenoid is released and the catapult launches a 12-ounce canned beverage.
Oh yeah, that's it.
Got it.
That's third.
Hey!
Let's go.
The next subsystem is the loading device. The loading device is run using a 28 BYJ48 stepper motor, one common in vending machine applications, a ULN 2003 driver, an Arduino Uno, and a separate 5-volt power source. The device can hold up to 6 standard 12-ounce cans and will dispense only 1 can at a time by completing a 90-degree rotation of the dispenser device whenever it receives instructions to do so from the Raspberry Pi.
The next subsystem is the rotating platform. It uses a HK T6A transmitter and receiver, commonly used for drones, to rotate the base. It is wired to an electronic speed controller, a 2S battery, and a motor that we used from last year's senior design project. Electronically, there are 4 main subsystems for this: the crank, the trigger, the loader, and the rotating base. The crank is powered off of a BTS 7960 motor controller, which is wired up to a 3S LiPo and the drill motor from a Ryobi drill. It is controlled by an Arduino Uno, which is wired up to the Raspberry Pi. The Raspberry Pi waits for a command for Alexa, and then will send a byte to the Arduino Uno via serial, which will instruct the Arduino Uno what to do, whether it be run the motor, run the clamp/trigger, or run the loader. The trigger is a solenoid running off a similar BTS 7960 motor controller and a 24-volt power supply. For the loader, it is running on a separate Arduino Uno connected to the first Arduino Uno via one line. It is hooked up to a falling edge interrupt, and when that's triggered, it'll run the stepper motor for 90 degrees or 1 full turn. The rotating base is running off of a HK T6A transmitter, as previously mentioned. It's very similar to a drone, how a drone works, where it has a receiver controlling an electronic speed controller via PWM, and it will rotate the base depending on the user input from the controller.
The Alexa subsystem can be broken up into 2 main codes. The first is ngrok. This application gives our private system access to the internet while still being able to be hidden behind NAT or firewall. Specifically, this allows for Alexa to interface with the Raspberry Pi. The second code is the Alexa response code. This code works in conjunction with Amazon Alexa skills. Once Alexa detects the correct command, the code on the Pi will then prompt the code on the Arduinos to run. Hey Alexa, ask SIPSender to send me a medium toss.
Sending a medium toss. Please confirm send.
Hey Alexa, ask SIPSender to confirm the send.
Confirmation received. Please stand by.
This is the Arduino code for the main Arduino that is running everything. It loops around and waits for a byte to come in through serial, and will do a different action according to what it receives. If it receives the command to run to notch 1, 2, or 3, we have a set amount of time that each of those notches will run to. So the motor will run for a certain amount of time, lock the solenoid, unwind and unspool the rope, and then unlock the solenoid, which will allow the rope to move freely and the can to launch. If other bytes are received, such as R, L, S, Z, X, or O, other actions will be performed that aren't more for the end user, but are just for calibration purposes, such as running the motor left or right briefly, just for testing and stuff like that. All of these running of the motors are performed via a PWM signal that is ran to the motor driver. This is the code for the separate Arduino that is connected to the loading mechanism. It implements the stepper motor library that is built into Arduino in order to turn the stepper driver accordingly. It uses a falling edge interrupt, and then when it is triggered, it changes a value so that the loop knows to rotate the motor 90 degrees.
Overall, the SIP sender can successfully deliver 12-ounce beverages to the target. The loading capacity allows for multiple consecutive throws, up to 4 to 6 cans. Multiple operations can be performed without moving or getting up from the couch. However, there are some weaknesses. There are only 3 launching distances, each notch being a plus or minus 2-foot range. This is due to the solenoid clamp being unable to clamp the smooth rope. So notches had to be implemented so that the solenoid could in fact clamp and we could trigger the system. It takes between 20 and 25 seconds per cycle, which is a little over our constraints. Additionally, it is very large and takes up a good bit of space inside.
Hey Alexa, ask SIP sender to reload.
Reloading. Please stand by.
Hey Alexa, ask SIP sender to give me a short toss. Hey Alexa, ask SIP sender to reload.
Reloading. Please stand by.
Hey Alexa, ask SIP sender to give me a medium throw.